Hello friends, today I'll be sharing my recent study on LSTM models, long short-term memory models. This is given to me as a prerequisite to study large language models. So I'm working on it. So let us start with artificial neural network. So it's a machine learning model. For a certain node, we have several input signals x1, x2, xm and several weights w1, w2, wm, which are to be estimated while this model while ANN gets trained. We have the summation factor and the activation model, which generally comes in the single node. So in sum up node, we do summation wixy, summation xi wi, and then on activation function we use say sigmoid model 1 by 1 plus e to the power minus summation wixy, and that's our output. So there are several activation functions which we can't see because of small fonts. There are several activation functions, but while training we use the gradient descent method to minimize the cost function and use the back propagation to estimate the weights, to estimate the best possible values of the weights while minimizing a cost function. So that's how a neural network works. So it's a free forward model. So we have a layer of input nodes where the inputs come in. We have a layer of hidden nodes. Now neural networks today can be of million nodes, and then there is a layer of output nodes. So signals go from left to right. It's a free forward model. So that's artificial network or artificial neural network. Then comes the recurrent neural network, which brings in a concept called memory. Now how it is formulated? The node is taking the input from a later node of a previous run. So that's why it is called recurrent network, and it brings in a concept of memory. It looks like a memory of which of that the network evaluated before. So that's the neural network. That's a recurrent neural network, and it's an improvement over artificial neural network. It works better for natural language processing models and time series analysis, etc. So that's recurrent neural network. Then comes the long short-term memory models. So here it's basically a recurrent neural model. The nodes are taking inputs from the later nodes of the past information, but on top of it, it has a forget node which selects the memory that are being incorporated. It allows some memories to be forgotten, thus creates two types of memories, long term and short term. So this forget get is an introduction for long short term models. Now we can do the mathematical formulation of LSTM. We can note down the parameters, the input vectors, forget gates, activation vectors, input update gates, activation vectors, and finally the weights of the edges. That we can do, and also we can formulate the interaction of the nodes. We can formulate the interaction of the nodes, how the forget node is working, how the input node is working, how the output node is working, etc. And we can use training and backpropagation while minimizing the cost function with gradient descent, and can have a good estimate of the weights of, and difference of parameters. There could be millions of parameters. And this LSTM leads to large language models, which came to us as ChatGPT. So we're not going to mathematical studies, so let us study some success stories of LSTM. In 2018, Bill Gates called it a huge milestone in advancing artificial intelligence when bots developed by OpenAI were able to beat humans in the game of Dota. I don't know what the game of Dota is, but it performed intelligently. In 2018, OpenAI also trained similar LSTM by policy gradients to control a human-like robot that had manipulated physical objects with unprecedented dexterity. That happened in 2018. In 2019, DeepMind's AlphaStar used a deep LSTM code to excel at the complex video game StarCraft 2. This was viewed as a significant progress towards artificial general intelligence. So that's the story of LSTM, and I'm studying the large language model now. Thank you.